so we're starting the new topic of recursion and finance. So recursion is it's a way of setting up formulas. So it's a sort of a language. And we're going to use that type of mathematical recursion language in our finance topic. So that's why it's called recursion and finance. And you'll see in a minute. And so we got this example at the start to sort of help you get an idea of what recursion actually means. So Johnny wants to save money for the future by investing in a low-cost listed investment company, Argo. Each week, Johnny gives $250 a week for his part-time job and deposits it in a share fund. And his parents give him $500 to start his long-term savings plan, assuming no dividends are received. So what we can do, there's a financial scenario, and what we can do is we can set it up in a recursion language. So here, this first column or this side of the chart here is showing you a recursion relationship. So you can see they give you what you initially started with. So they call it VO, meaning zero. Zero time has passed, okay? So VO is the initial starting part. And his parents gave him 500. And then what we do every week on, so this is like a weekly model, he adds his 250 wage into it. So this recursion relation, this is the formula there that shows you how you get the next term. So he would get the next term by adding the term before. So in this case here, say it was after 1 week, he first had 500. That would be what VN was, the 500. Then you add 250. Then the next week, so say we would start off with 500, and then say week 1, we add the 250. So we've got 500 plus the 250, so we get 750. And then we go week 2, it'll be the 750 plus the 250 equals 1,000, and so on. So this is a recursion relationship. So this n plus 1 is just a way of saying how you get the next term. You use this formula, okay? So the n plus 1 is not a mathematical, operation. It's just a label. And if you want, you can say, maybe if you want to write Vn at plus 1, just is how to get the next term. Okay, so that's what we'll see, and that's what recursion is, using that, how we get the next term using a formula. So we have a recurrence relation, so that's what a recurrence relation is, where they give you the beginning and then they give you a rule on how to get the next term. Sometimes, say we were doing this for Johnny, it might be after 5 years he's done this all the time. We're going to want to know what he earns after 5 years or so. So what we then do is we change these recurrence relations into an nth rule. So here, say this rule here, we would say this is a rule of how to get any term. So say I said 2 years. So 2 years, this is a weekly thing. So we're going to say that's 108 weeks, yeah? So say if I wanted to find V108, what I would do is go 500 plus 250 times 108. Can you see, that would make it easier, otherwise we'd have to keep clicking or keep adding and adding and adding to get up to 52. So we're going to see this throughout the thing, but just to give you an idea of why we have, this is the recurrence, so they will say, write the recurrence formula. That's what you've got to do. You have to write a VO and then a rule. If they just want the nth term formula, it's going to look like this, where you have Vn equals something. All right, so we're going to talk about sequences here. So we're going to talk about sequences. So we could have a sequence of numbers. So say, for example, I could have a sequence of numbers like this, okay? So each one of these numbers we know as a term, okay? So we might call this term 1, and this could be term 2, 3, 4, 5, 6, and so on, okay? So they all have a term. And now sometimes we can see in our sequence, so we can see here we're adding 2 every time. That's what's happening there. So when we, as we said before, we can set up this, we've got a sequence of numbers, we could set this up in a recurrence relation. So remember, we're going to tell you now, so a recurrence relation means that we have to first state our first term. So we call that VO. So in this example, it's 2. Okay? And then I need to write a rule of how I get the next one. So how I get the next one is I take the one that we've already got, so say the 2. So that's what VN means, the one that you're presently on. And then we would, in this example, we would add 2. So that's how we got the next one. So that's me setting up a recurrence relation for my little example there. Okay, so here they've got another example here. They said start with 10, and they said the rule was to add 5. So you can see they've written VO is 10. How do I get the next one? I write VN and I add 5 because that's what the rule is saying. So sometimes we might get a rule. So we've got this recurrence relation here, down here, and we've got VO is 300. And here's the rule on how to get the next one. So what we're actually saying here, how we get the next one is we're going to multiply by 0.5. Then we're going to subtract 9. That's what the rule is saying. So and then the questions will often ask you to write down the first 5 terms of the sequence. So what I'm going to do now is we're best to do these on the calculator. Some are easy, you can do them in your head, but you're best to see it on the calculator because then you can visually see what's going on. So I'm going to just pause it here and show you. Okay, so we saw in our calculator that we typed the 300, and then when we did it down here, we saw answer, and we times it by 0.5 and minus 9, and we got 141. So this says the first 5 terms. So there's term 1, 2, so 1, 2, 3, 4, 5. So you would write those numbers down like that. There's our answer. All right, let's do some exam questions now. Okay, so in this exam question, so in your exam, finance is a compulsory unit. So you'll go through the core, like all the data questions, and you'll get there'll be 16, this is in the multi-choice, then you'll hit finance, and 17 would be your first financial question. So the earlier the finance questions, the easier they are, okay? It does progress like that. So expect these to be fairly easy. So here it says, consider the recurrence relation. So you can see here too, we don't always use the letter V. I like to use V because it's the value, because we're often talking about the value of something. But they've decided to use A, and they're saying AO. So that's what the recurrence relation began with too. Now they're asking you to, what are the first 4 terms? And here they've given you the rule. So you could quickly do this on your either on your head or in your calculator. So you'd have 2, and then you're going to say in your calculator, if you did it, you did the 2 times 3 plus 1, so that'd be 7. Yeah, and then you keep pressing enter. So the next one would be 7 times 3 plus 1, which would be 22. So you knew the very first term was 2, so you could have got rid of these, and then I've already up to the only answer there is E, so I'd move on quickly. All right, and here's another one, and you can see it's question 17 again. It's the first question in the exam of finance. So a sequence of numbers is generated by this recurrence relation. So yep, there we go again. They're saying it's a recurrence relation because they're writing it like this with the initial one and then a rule. And what's the value of P3? So the way I'm going to find P1 is I'm going to use this formula. So it'd be, the next one would be 3 times PO minus 1. So it'd be 3 times 2 minus 1. So that would be 5. That's P1. So then P2, you would do the rule. It'll be 3 times the one before, which is 5, minus 1. So that would be 14. And then P3 would have been 3 times that 14, which is 42, minus 1, which is 41. But you can just quickly do it on your calculator, but I'm just showing you there's how you could do it with your recursion language. So this was P1 there, this is P2. So you're going to find P3 by using the one before, which is P2. All right, let's keep going. All right, so with these, when we have a recurrence relation or a formula, a sequence, when we are adding the same thing or subtracting the same amount in our sequence, that's an arithmetic sequence. So if you look, so here it says you're adding the same thing. So for an example, I'll put an example here. So an example could be if we began with 2 and we saw it before, where we said, and we're going to add 2 every time. So you can see your sequence, your sequence would have been 2, 4, 6, 8. So you can see we're always adding this common difference, which is 2. Yeah, we're always adding the 2. That's that common difference, the D. They often call it D. So when you have an arithmetic sequence, you're always adding just the same amount. So this one, we're adding 2. So if you were to graph that, so if you look here, if you said this is the number of terms after, so this would be after 1 term, 2 terms, 3 terms, and so on. You could see here you go. So if we were graphing this, we'd have like the 2 up here. If we did our little example we had there. So 2 would be there. This would be 4, 6, 8, 10, 12, so on. So you can see you're always adding. So it actually is a straight line, isn't it? So when you have an arithmetic sequence, it's this straight line. So you might want to write that there. So an arithmetic sequence it's a straight line. And this is a growth one. So when you're straight line up, when it's growth. So when you might write it's growth and you're adding same amount. Okay? So if you have, when we're just like minusing something, so you can see you can either do it where you subtract the same amount. So I'm going to say, for an example, I might have started on VO, I'm going to say is 20, and I'm going to say I get the next one by, I'm going to say subtracting 4 or whatever. So what the sequence would have looked like, you would have had 20, 16, 12, 8, 4, and so on, right? So if you look here, this one would have been here 20, and this would have been 16, 12. So what you can see is still arithmetic because we're always minusing the same amount. So we're always minusing 4. So when you have decay, so arithmetic decay, it's a straight line down. So we can see that it's going straight line down, and it's a decay. Oh, sorry. We're going to say it's decay because it's minusing the same amount every time. So if you saw a scenario where it's subtracting just the same number every time, that's arithmetic decay. So then we have that, and now we also now have geometric sequences. Geometric sequences are when you're multiplying the term before, by a number. So I'm just using, that means before, by a number. So if you're growing, if it's growth, you're going to multiply by a number bigger than 1. So here you might say you're multiplying by number bigger than 1. So if you want, let's put an example there. So say I had, so I'm going to say an example. Say I had VO was 10, and the way I got the next rule was I'm going to say 2 times Vn. So it means 2 times the one before. So you could say you were going to start off at, you'd have 10 here, and then your next one would be 20, and then your next one would be 40. So you can see that it's actually doubling. It's not going up by the same amount, you're multiplying it by the same ratio. So we might just change this R to a capital R. We're going to refer to it as a capital R. So just change that. So really, if we're doubling it, we're timesing it by 100%. So we're timesing it by 2. So anyway, so that's the growth. Now, if you want to look at the graph here is a curved line up. So you might want to write that in there. When it's geometric, so you're timesing by a number greater than 1, it's a curved line up, yeah? And then when we have the opposite, so we're going to look at decay. So you can see decay is a curved line down. And when you're doing a decay, that means you're reducing it. So you're going to be multiplying by a number less than 1. So what I mean by that, so you might say, for example, we might have VO is, I'll say 200, okay? And we might say we get the next one by timesing it by 0.5. So see, that's a number less than 1. So you would be halving it every time. So say this guy would be 200, the next one would be 100, and the next one would be 50. So you can see it reduces by not the same amount, but it's reducing by the same percentage or ratio. So that was a little bit of an overhaul, and because we've got it all on a summary page, so we've gone through it. We're now going to slowly go through each one, so don't stress, okay? This is just a little bit of a quick summary, and that will help you. Okay, so just to go over it now, so we're going to see if we have a recurrence relation. So these are all recurrence relations because they're stating an initial one, and then they're giving a rule. If it's arithmetic growth, we're going to see the same amount added. So you might write that there, same amount added. When we see it's arithmetic decay, you can see we're seeing the same amount subtracted. So same amount subtracted. So here's another there are other examples. When we have growth, geometric growth, you're going to be timesing by a number bigger than 1. So we're timesing by number bigger than 1. And then this last one, when we have geometric decay, we're timesing by a number less than 1. So you might have to, they might ask you to pick out the one that's a geometric decay. So you do need to know these. So you've got a little summary there you can remember, so it'll help. So here I've done a few more exam questions, so let's give it a go. The following recurrence relation can generate a sequence of numbers. Number 13 appears in this sequence at T what? So this is T0. So T1, they've got the rule there, would be found by taking T0 and adding 3. So the T1 would be 13. T2 would be what? We're just adding 3, so that would be 16. T3 would be, oh, well, we've already gone past. So what was 13? So yeah, it was T1. What type of sequence is this? Is it decay, growth? Arithmetic growth. Good. So here you might want to write that. That's always good to keep practicing that. So you go, this is arithmetic growth. Why is it growth? Adding. And why is it arithmetic? Same amount, because you're adding the same amount.